Hello. Hello. Can you hear me? Everyone hear me? So we're going to be talking about email. This is me. I'm rjbs. I'm a CPAN author, and I have written a lot of code to handle email. This is some of it. I have written a lot. I work at a company where all we do is email. I cope with email. I think about email all day at work. And I have come to tell you what I can about email. But the most important thing that I can tell you about email is that email hates you. And email wants you to be very unhappy. The favorite thing that I read when I was reading through all of the specifications for how email works is this guy. Several of the mechanisms described in this set of documents may seem somewhat strange or even baroque at first reading. But in particular, compatibility is always favored over elegance. And that's what we're going to see over and over here. You're all Perl programmers, so you know about favoring compatibility over elegance. Email takes it to an entirely new level. So why is this information useful or interesting? It's not necessarily useful. This talk is probably not going to tell you the kind of things that you should do when you get back to the office. It's not about skills that you need to have, how to write email, how to understand email. The only thing that this talk is really going to tell you that is useful to you is that any code you have written is terrible. Any code that you have written to deal with email, you are wrong. That's okay. All the code I've written is wrong too. Code that you write to work with email is always wrong because you can't ever be right with email. Please stop writing email code. I'm part of a very loose organization we sometimes call the Perl Email Project. Mostly what we do is take care of the modules whose name starts with email, : I've given a lot of talks about what we do and how we feel about these projects, but the most important thing I can tell you is that we really also hate email. Email's simple. So the first thing I want to talk about is some libraries that you've used in Perl. Mostly today I will be talking about email itself, but first we'll talk about some Perl libraries for email. Email Simple most people have seen and wonder whether you can use Email Simple. Is Email Simple a library that is a good library to use? No. Email Simple is okay if you are only producing new email. You're not reading email that comes into you. If the email that you're making is only ASCII, no part of the message is anything other than ASCII. If you have no chance of any 8-bit character, even in the headers, and you are not replying to a message. Oh, and you don't know the real names of the people you're sending to, only their email addresses. If all of these are true, maybe Email Simple will work for a little while. But soon you'll need Email Mime. Email Mime is going to do a little better. It will let you have foreign to me characters in your mail. It'll let you have attachments on your mail. But it's a naive module. It assumes that you're going to do things in a reasonable way, that you're looking at mail that comes from reasonable people. When you need to deal with mail from the real world that comes from people who are using things like Outlook, you start to need something like MIME Entity. MIME Entity gets a little better, it gets things more right, but email is very, very complicated. So fortunately, someone wrote a library that tries to get everything right, absolutely everything, ever specified in email works with mail message. The problem is mail message is a little bit complicated. It's not really one class. There's actually a few classes you need to learn. This is some of them. I can show you all of them if you are all prepared to squint. This is the mail message ecosystem. As I said, every day, all day, I think about email. I do not use mail message. It's too much. Other people who worry about email every day are spammers. We all know about spammers and what they do. And they provide one more reason to think about the email specifications and how they work. And that is, if you understand how email works, you know what the specifications say, you know how to abuse them in the right way, you can send mail that to humans is obviously an advertisement, obviously spam, but that programs will never understand because email is too hard for programs. It's much easier for people, in a way. When we talk about email and the specifications behind email, people like to think about these two RFCs. I'm going to talk a lot about RFCs. An RFC, many of you probably know, is a document that describes how a system on the internet works. It's the specification, more or less. And we talk about RFC 822 and RFC 821. These guys give us email. But in fact, email existed well before that. There used to be RFCs in the 500s, RFCs in the 600s, and they're great. You can read those, and it's beautiful. Email makes sense. You could write an email program in 10, 20 lines of Perl. There's nothing to worry about. But then, RFC 724. No, this is where email starts to go off the rails. RFC 724 gives us something called header folding. Let me tell you about header folding. Here's an email header. Very, very standard, easy to understand email header. But I want us to pretend that we do not have a 200 character wide terminal. We have a 44 character terminal or a 20 character terminal. Very narrow. This is what computers were like when they were popularizing email. People had very narrow terminals. And this might not fit. So they needed a way to display this that everyone could understand. And what they did was they said, you can just fold it. And we've all seen this. It seems very natural. You look at something that looks like this. Great, looks good. But why stop there? You know, what if our terminal is 15 characters wide? Well, we'll fold it twice. It's totally reasonable. We can do this. And as long as we're at it, we can keep folding and folding. This is legal. And is this really silly and ridiculous? Yes. This is stupid. So can we ignore it? No. We are going to see content like this in email because it is legal and because someone is either a jerk and wants to see whether you have a bug. You don't really follow the specification. You didn't allow me to fold my header 16 times. Or because they're trying to abuse your system. You will see this. And sometimes you will be wrong to reject it, and sometimes you will be wrong to accept it. It's very complicated to know which is the case. So the folding occurs by inserting what we call the token is called linear white space. When can we fold? When can we insert linear white space? The specification says you can insert linear white space in reasonable places. So wherever you think it's okay, that's fine. That's where you may insert it. And it's not going to be hard to program. The programmer can simply get the unfolded thing because we will assume that there is another lexical analyzer somewhere. So it's easier for the programmer because there's a programmer who solved the problem. Right? But we all know that we're the programmer and we have to solve this problem. And it gets worse. Not only can we have these headers fold and fold and fold and put space between tokens wherever they want. Space doesn't just mean character 20. It's not just spaces and it's not just line feeds. It's also comments. So you can insert comments anywhere you want. When a comment is used to act as the delimiter between two sequences of symbols, it is lexically equivalent to one space. So anywhere you could put a space, you may put a comment. And when you see a comment, you must treat it like one space. So this is exactly equivalent to this, which is exactly equivalent to this. And isn't it good that we could write this? It's so much easier than having to understand that big, complicated thing we avoided when we had to think about this. Right? This is terrible. That's nice. So this is part of a concept called comment folding white space. If you ever want to see an email programmer turn red in the face, ask him about comment folding white space. It is horrible. Now, over time, email programmers realize that comment folding white space is the devil, and they try to get rid of it. So you used to have this, right? And this is still allowed. They can't actually get rid of this because you have to be backward compatible, not elegant. They stopped allowing this. You can't have a blank line. Now you can't see it, but right around here there's actually some spaces. So that used to be okay, it used to be folded, but now it's not. So they saved us from that. That's a big help. Other things that we can look at in the header that are going to get bitten by comment folding white space are these guys. These are many of the legal ways to show a date in an email header. They're not great. Now, they're not ISO 8601. They're not very standardized, very easy to read. But they're not bad. We could parse this in just a little bit of Perl. The problem is, these are composed of tokens. There's a year token, there's a time zone token, there's a hour and month token. And remember, any place we want between tokens, we can put white space, like this. Actually, I'm pulling your leg. This is not legal. You can't really do this because empty comments are not allowed. Right? This is no good. Now, when we update this in RFC 2822, because 822 gets replaced by 2822, which is supposed to fix lots of problems, and later we get one of the 5000 series. They fix it by saying you have to write it this way. And if you want a comment, the only place you may put a comment is at the end. The problem is, this is great, right? This is great, it fixes the problem. The problem is, you still have to accept this if you see it. Because this is what the grammar says. There's lots of grammars. Reading the grammar in the email specifications is a lot of fun, if you like fun the way I do. It says something like this. A date is a day, a month, and a year. A day is 1 or 2 digits. A month is one of the short English months, and a year is 4 digits. That seems totally reasonable. That's how you want to write a date. I have no argument with that. But this isn't really what the specification says. The specification says it's this or the obsolete form. And what's the obsolete form? Well, it's some comment folding white space maybe, and then some numbers, and maybe some more comment folding white space, and then maybe some numbers and some more comment folding white space. So the specification can start saying, please do things reasonably. But they can't actually say the totally crazy, awful, sick, scary, wrong thing is illegal, and it's always allowed. In fact, what the text, the language in the RFC says, it must be accepted and parsed. Now, this was just the head, right? We're just only talking about the header of the message. What's the body going to be like, right? This is going to be really bad. So what are we going to do? What's the horrible, horrible thing in the body going to be? It's this, right? A message is the headers, and then maybe some blank lines in the body. So message text. Message text is going to be really bad, right? No? Message text is a sequence of 0 or more ASCII characters. And that's it. That's not so bad. A whole bunch of characters. Okay, they're 7-bit. I mean, that's not great, but this is 1976 or something. It's understandable why this happened, but it's not really okay. Because even though this is the format of the message, you don't just write a message and stick it in a box. You send it to somebody. How do you send a message? You use SMTP. SMTP is an RFC 821, and it's the Simple Mail Transfer Protocol. And like all of the best names in software, it is a complete lie. In SMTP, when you send a message, you send it in lines. Text, enter, text, enter, text, enter. And you can't have a line more than 1,000 characters, including the CRLF. You may not fold lines in SMTP. So that header folding, that's in building the message, not sending it. And there is no encoding for 8-bit characters, which is fine. Because, I don't know about you guys, I don't use 8-bit characters. I talk American, and I'm perfectly happy with US ASCII. So the solution here is everyone will just speak American, problem solved. Well, some people were not happy with this, who wanted to send messages in their whatever funny languages with squiggly characters. So they come up with a solution, and the solution is MIME. MIME really gets standardized in 1341, and that's where the fun is. Before that, there were precursors to MIME, things we had before MIME, and my favorite is probably RFC 1049, which looks a lot like MIME, but it has a short list of what we would now call MIME types, right? You can send text, you can send image, which I think meant TIFF, you can send XPM or something like this, and you could send TROF. TROF is one of the short list of formats. It's great. There's some other ones, and if you see me in the hall, ask me. I would love to tell you about them, but we'll just talk about MIME. 1341 is replaced by 2045, 2046, 2047, 2048, 2049. That's how complicated it's going to be. Here's the message we want to send. We want to send this message, but we can't. We can't send it. Why can't we send it? Because we've got these characters here. These are Latin 1 characters. A diaresis. We can't send it over SMTP. SMTP is only 7-bit. So how do we send it? We're going to say that we are going to encode it. All right. So we've taken those 8-bit characters and turned them into base 64. Everyone here probably understands this. It's not complicated. The problem is, what we have encoded are the bytes of the message. So when you receive the bytes, what do you do with them? Well, this is the text we had, and these are the bytes we sent. But if someone gets this on an obsolete language that assumes Latin 1, like Perl, you're going to print this. If you send it to somebody on a really obsolete system, like a Mac, they're going to see this. We need more information, so we're going to give more information. We will say that we're going to send this in text plain UTF-8. Solves the problem. It even solves the problem of line noise, because you can stick any old character you want into that message as long as it's not a legal base 64 character, and it's ignored. So you can take your base 64 message, inject characters all throughout it, and it still works. Early error correction. But does it really work? It's not entirely clear, because it says characters not found in base 64 must be ignored. You receive a base 64 message, you begin decoding, and if you see a character not accepted, you must ignore it. But a warning message might be appropriate under some circumstances, or maybe even an error. I don't know. Do what you want. It's okay. Have fun. Spammers love this stuff. This is great for spammers. A spammer wants to send you this message. They want you to buy donuts. They want you to buy Viagra or Apple stock or whatever the spammers are selling today. Anybody who writes a terrible Perl email filter, as I have written many times, and says something like, if the message body contains Viagra, delete it. Well, they won't send you this. They will send you this. Their message has now been encrypted. It's not really encrypted, but your software to filter this mail, to process this mail and think about it, has to be much, much more complicated. It has to know things like, if I'm base 64 decoding and there's characters I don't expect, I better ignore them. Because you have to. If you don't, but your mail program does, then you ignore the message in your filter and it gets to your mail program and you end up having to see these ads. I'm just going to skip through some of these things that are not so interesting, right? Here's another encoding. Here we've decided instead of using base 64, we're going to use quoted printable. Quoted printable is nice because instead of turning everything into hex, you can see most of the message if it's in something that's a superset of ASCII, which most messages are. Even most messages sent in CJK world are largely ASCII because they're HTML. And that's a huge amount of ASCII over top of the wide characters. So you can send this and it looks really nice. You just take the funny characters, funny to me, and you turn them into equals hex value, equals hex value, and so on. This is a 2-byte UTF-8 code point. And if you're not sure which characters are safe, it's okay, you can encode more. Maybe spaces aren't good. Maybe we shouldn't have spaces. We'll encode the spaces. And we can still sort of read this. And maybe we'll just encode everything, right? And we'll start doing this. This becomes a problem. If you can tell, the octets I encoded here, they're very dark. The octets here are carriage return, line feed, carriage return, line feed, which shouldn't be a problem except the specification actually says if you want them to display like this, just put the carriage return line feed. But if you encode it like this, your mail client should show you this. Nobody gets it right. Mutt gets it right. Mutt does the right thing. Everyone else does not. And this is a case where doing the right thing will only make people unhappy. If you actually show them this, I am the only person in the room who will be happy. Everyone else will say, why are these control characters here? Or more likely, they'll say, what is this? What's this noise in my email message? You can't get email correct. Doing email according to the specification is no good. And ignoring the specification is also no good. This is the world of email. But let's stick to real common cases. We've got this message and we want to send it to people. But we don't just want to use email addresses, right? We don't just want to say, these are the recipients. We want to put their names in the message. So like this guy, right? We'll put his name in the message. No problem. Nice 7-bit name. But then we want to send some more messages to these guys. And they've got funny names. Their names don't fit in 7-bit characters. So what are we going to do? Great, we'll use content transfer encoding. Right? We've already seen how to do this. We'll just base 64 encode this stuff. But content transfer encoding is for the body, not the header. We can't use content transfer encoding. We need a new scheme. One for the body, one for the header. And that gets us to RFC 2047, encoded words. Encoded words are just like words, but encoded. They look like this. An encoded word starts with a question mark, ends with a question mark, and there's 2 question marks in the middle because it's really questionable. Here's our spec. Here's what it's going to look like. We'll take this header. Here's one of our 2 headers. We'll turn it into question mark, KOI-8 Russian encoding, quoted printable, and then the octets. And then we're done, and then the email address. Fairly understandable. This guy, we're going to encode his in where did I go? In Mac Arabic. Well, whatever, you saw it. The problem is, what if we wanted to give his full name, some of it in Mac Arabic, some of it in ASCII, some of it in EBCDIC, and then the rest. You can do this. You could do this in 1987 or something. And in 1987, there was nobody who could read this message because no one had useful systems for transcoding between Latin 1 Ebsibit and, what are we using, Mac Arabic. It just didn't exist, but you could do it as much as you want. If we want, we can even encode things that don't need to be encoded. Like we can take this guy's 7-bit name and encode it like this. But there's a problem. Does anyone see the problem? The problem is the space. No spaces. So we'll fix that. Right, there's the problem, the space. We'll fix that with an underscore. Earlier, when I talked about quoted printable, which is we're using quoted printable, when I talked about quoted printable, I didn't mention that you could use underscore for a space. Because you can't in the body. In the header, it's okay. In the body, underscore means underscore. So there are actually 3 encodings we talked about. Header QP, body QP, and base 64.
Could you encode it as 2 separate words, each with its own encoding and a space in between them?
The answer is yes, and the question was, can you encode this name as 2 encoded words? Let's say this one in Latin 1, this one in Latin 2, separated by a space. Yes, you may. Absolutely. So, here's our whole header. We've got some encoded strings, some single strings. Great. This is fantastic. Also, why stop here? Why not, keep track of what we're actually doing? Throw in some comments. And notice I'm using encoded words in comments. Even though comments are white space, they are structured white space that may be encoded. You also might notice this message is a reply. What's it a reply to? Well, it's a reply to the annual report, which has been attached. Oh, we need attachments. Great. This is what an attachment looks like, right? That's nice and simple. It's a picture of a document. That's easy. It's not how it works. It looks like this. This is actually not so bad. We just said it's a Word document, Microsoft Word, and it is base 64 encoded. Okay, well, it's a whole bunch of bytes encoded. That's not so bad. And we need to put a file name on it. The MIME specification says, don't worry, you can put a file name on it, and we'll tell you how in the next RFC. 9 months later, they tell you how. You can start with this. Okay? It is a Microsoft Word document with a title, which is Progress on Project Maelstrom. Of course, the problem here is clear. We have funny characters. Here they are. Funny characters. So we can't use content encoding because it's not the body. We also can't use encoded words because parameter values on the right side of the equal sign are not words. There's something else. And there's no solution yet. There'll be one later, but at this point, no. Once again, just stick with 7 bits. It ought to be enough for anyone. The solution is, everyone ready? This. We don't just say title equals, we say titles equals with a star. And the star means we're going to encode the bytes, UTF-8. We also know the language now. Not only is it encoded, it's an English word encoded in UTF-8, and we URI encode the bytes. So we've got URI encoding, header QP, body QP, and base 64. There's also other ones that I'm not mentioning. These are the ones we really see every day. If you want, you can also do things like encode the spaces. But there's a problem. Remember at the very beginning we talked about headers get very long. And so to make them prettier, instead of saying there's a presentation layer, instead of saying when you display a message, consider wrapping it, we said when you build a message, in serialized message, you may wrap the headers. Well, here we've made a very long line, and we might want to wrap this. And in fact, everyone decided wrapping was such a good idea that now it's mandatory. By the time the specification comes out, you must wrap these. But we can't, there's no white space. There's nowhere to break the line. You can only break at white space. It's okay, we have a solution, and the solution is this. Here is the title, presented in 4 parts. The first part is in UTF-8. The second part is also in UTF-8. The third part is in UTF-8. The fourth part is in ASCII. Don't worry, I'm sure you can figure it out. And yes, if you wanted, you could say UTF-8, EBCDIC, Latin 2, anything you want. There's an encoding called Unicode stroke 7 stroke 1 stroke 1. Python uses it. It really means UTF-7. But you can call it by lots of names. Later you can start saying this. By the way, this is an attachment. Oh dear. This is an attachment. And in addition to having a title, it also has a file name, which is great. You can also put more things on it. Yes, it's an attachment. Here's the last modification time. So your message can really be a file system. It has all the files with their C time, their M time. You can have their size. But unfortunately, the size is just advisory. You can't rely on it to read the message. And yes, this is legal. Of course you can put comments here. Why not? But the mistake most people make here, and this is a silly niggle, this is a silly thing for me to complain about, but it really makes me angry. People put a semicolon here. You may not. Semicolons come at the end of something only if there is something else. And if you put a semicolon at the end, some things will not read your mail. So, we want to actually attach this stuff. How does that work? We're going to say the message is not plain text, it's not MS Word, it is multi-part. This message has many parts. And then, there is a boundary. The message begins and ends with the boundary. Inside of the boundary, we have more messages. They are just like any other message. They have a content type. They have content disposition. They could have date headers and to headers, anything you want. And we would put the plain text message, which is probably the body. Right? It's going to say, hey everyone, here's the report. And then the Word document, which is the attachment. It's the thing that pops up as a little icon. This actually seems pretty good. I can look at this and say I have no problem with this. It's a little silly, it's not great, but it works. The problem is you are totally free to write before and after the outermost boundaries. And what are you supposed to do with those? No one knows. What tends to happen is if someone gets a message in a client that cannot read MIME, which is none of them, everybody can read MIME, more or less, it will display something. So what you really end up writing is something like this. Your client does not support MIME. My favorite piece of spam ever, and I have seen a lot of spam. The preamble said, get a capable email client. Yeah, so you can read the spam that I'm sending you, because it's really important. Okay, I'm going to skip through a few things. Yes, so next we can talk about SMTP. We'll call the messages done. We understand messages now. We can write message code with no bugs. It's great. SMTP is how we send mail. SMTP is the transport layer for messages. And when we send mail, we have the message, we want to send it, and we need the addresses. Ooh, the addresses. I only have a couple minutes left. I'm going to talk about addresses. Because whenever you hear about how bad email is, what you really hear about are the addresses. I got an email like this. It said, Dear RJBS, I was testing your library for email addresses, and it told me, the silly thing, that this was a valid email address. And of course it is not. Well, here's the grammar. And we can drop some things that don't matter. The grammar comes down to something like this. So the domain, the guy's email address was something like John at lots of punctuation, a little string of Perl program. Well, a domain is any sequence of characters as long as it is not these. I can think of a lot of characters other than those. How about exclamation points and hash marks and backticks and forward slashes? You can put all kinds of crap in there. So this is a legal address. Everyone knows that. So is this. That's a valid email address, my friends. You can send mail right to a web address. It doesn't work, but you can do it. These are all valid. This is valid. How many headers in this bottom example? 2, not 3. We have escaped the new line. So that guy's address is ricardo to rjbs at cpan.org. You think your email filter is going to read that correctly? It's not. We can do groups. I'm flipping through many things because we were running out of time. But I'd like to ask, I think I missed one very important slide. Right here. This is my favorite slide to ask about. How many valid email addresses on this slide? Take a minute before I tell you. See how many you can guess are correct or not. The answer is 1. There's 1 valid email address. And whichever one you think it is, you're probably wrong. This one is no good. You may not end the local part with a dot. As I recall, actually some Japanese phone carriers do this, which leads to problems, but it's not legal. You can only have dots between words. This one is no good. Colon is a special. It may not appear in the local part. This guy, right here, there's no dot on that I. That is a Hungarian Turkish character. It is not Latin one. That is not an encoded address. This looks good, but it's in parentheses. It's a comment. This thing looks okay, right? That's a nice encoded name. But here we've ended the domain in a dot. Everyone knows you can end a domain in a dot, but not in email. That dot is not allowed. This is the only valid address in this header.
Which round of RFCs are you going by for these validity rules?
I believe this is 2822. I'm not sure if this still works under 5322.
But 822 allowed some of that stuff.
822 allows all of that, yeah.
So those are all valid?
Those are all valid forever, yeah, but they might still be explicitly valid. I would love to keep going and talk to you about SMTP, but I think I will have to wait until next time I come back for my next talk. And I have just a minute maybe left if anyone has any questions. I will answer them.
I have questions, but I'm not sure if I can make it back.
Dan, I want to thank you, well, everyone who's listening. Dan, who maintains Encode. Encode is so helpful in a lot of things I do. And Encode works flawlessly except for the email portions. And whenever I find a bug in the email portions, I never know what I know it's wrong and I never know the right answer. And so Dan, all the work you do, I appreciate so much. Anyone? Yes?
About email sender module.
Yes.
Email sender ムースがうざいっていう意見なんですけど、do you have a plan to switch Moose to any Moose or something? Email sender module.
So the question is, will I switch email sender to Moose? I would to any Moose. I don't plan on it, but I do like good American beer, and I could be bribed, but I don't think it will happen. But talk to me sometime, and we'll see. Okay. Well, thank you very much. It was a lot of fun. Thank you.